So, you want to become an AI engineer in 2026? Well, you've come to the right place. We are about to lay out a complete step-by-step roadmap that's going to take you all the way from the absolute basics to building a portfolio that actually gets you hired. Let's jump right in. And let's be super clear about one thing. This isn't some trend that's on the horizon. It is happening right now all around us. The AI wave has already crashed ashore. I mean, we're talking about everything from AI agents that work for you to the generative models powering billion-dollar startups. The demand for engineers who know this stuff is absolutely exploding, and this plan is your guide to mastering that wave, not just riding it. But before we start our journey, we gotta get the lay of the land. You know, the AI world loves to throw around a ton of buzzwords, so let's just quickly map out the terrain so we know exactly what we're talking about and where we're going. Okay, think of it like this. At the very top, you have this huge, massive umbrella called artificial intelligence. It's the big, overarching idea of making machines smart. Now, tucked inside that umbrella is machine learning, which is a specific way to achieve AI. And then, inside that, you have an even more powerful subset called deep learning. So it's really a simple hierarchy. AI is the big field, ML is a part of it, and DL is a specialized part of ML. So what's the real difference between machine learning and its superpowered cousin, deep learning? Well, traditional machine learning can work pretty well with smaller amounts of data, but it usually needs a human expert to tell it what to look for, to manually point out the important features. Deep learning, on the other hand, is an absolute data monster. It needs massive data sets to shine. But, and this is the magic part, it figures out the important features all by itself. This makes it incredibly powerful, but it also means it's often called a black box, because sometimes even the people who built it don't know exactly why it made a certain choice. All right, let's get to it. Step 1, forging your tools. Look, before you can build any of the cool stuff in AI, you need a rock-solid foundation. Seriously, this isn't a step you can just skim over. It is everything. Your foundational toolkit really boils down to 3 main things. First up is Python. It's pretty much the undisputed language of AI. Then you've got the math. Now, don't panic. The goal isn't to become a mathematician. It's just to get what's happening under the hood. And finally, you gotta master your dev tools. This is your digital workshop where all the real work gets done. So what should you actually focus on here? For Python, it's all about writing clean, professional code. Think functions and classes. For math, you don't need a PhD, but you do need a solid working grasp of linear algebra, a little probability, and the basics of calculus. These are the engines that make the models learn. And for your tools, you need to get really, really comfortable with VS Code, and especially with Jupyter Notebooks and Google Colab. They're basically playgrounds built for rapid AI experimentation. Okay, with that foundation in place, it is time for your first real quest, applying those skills to the essentials of machine learning. This is where all that theory starts to get real, and you actually start building things. Now, there are basically 2 main ways that machines learn. First, you've got supervised learning. This is where you feed the model data that's already been labeled. You give it both the questions and the answers, like thousands of pictures of cats labeled cat, and it learns the rules. Then, on the other path, you have unsupervised learning. Here, you just dump a ton of unlabeled data on the model, and it has to find the hidden patterns all by itself, like grouping your customers into different segments without you telling it what the segments are. To get started, you're going to need this armory. Scikit-learn is an amazing library for training all sorts of models, and pandas is absolutely essential for slicing and dicing your data. But honestly, the best way to learn is by doing. So you have to jump into these classic starter projects. Things like the Titanic survival predictor or a handwriting recognizer are perfect for learning the entire workflow, from getting the data to making a final prediction. Okay, you've got the essentials down. Now it's time to level up and tame the beast, deep learning. This is where so much of the cutting-edge, headline-grabbing AI stuff is happening right now. So what is at the absolute heart of deep learning? Artificial neural networks. And yeah, they're inspired by that incredibly complex web of neurons inside our own brains. A network is just made of layers of these little nodes that process information. And the deep part? That literally just means the network has a lot of layers. The more layers you have, the more complex the patterns it can learn. It's that simple. In this world, you're going to run into 2 main types of networks all the time. CNNs are basically the visual experts. They're the masters of understanding images and power things like self-driving cars. Then you have RNNs, which are specialists in sequences, like understanding a sentence or predicting where a stock price is going next. And to build these things, you'll pretty much use one of 2 major frameworks, PyTorch, which is loved by researchers for its flexibility,
or TensorFlow, which is an absolute powerhouse for getting your models out into the real world.
All right, at this point, you have a seriously powerful set of skills. But to really truly stand out in the job market, you need to specialize. The next step is to pick a path and just go deep. This is how you become the person everyone wants to hire. So, what are the hottest fields to jump into? Well, generative AI is obviously exploding. This is all about working with models like GPT to create new text, images, and code. Then you've got natural language processing, or NLP, which is focused on teaching computers to truly understand human language. And of course, there's computer vision, giving machines the power of sight to analyze images and video. The key is to find the one that genuinely fascinates you, the one you can't stop thinking about, and just dive in headfirst. And that brings us to the final and maybe the most critical step of all. You can have all the skills in the world, but if nobody knows you have them, it doesn't really matter, right? It's time to build a portfolio that actually gets you noticed. So here's how you do it, step by step. First, all your projects go up on GitHub in clean, polished repositories. Second, you have to write fantastic README files. A good README with pictures and clear instructions is like a landing page for your project. Third, share your work. Write a post on LinkedIn or a short blog explaining what you built and why it's cool. And finally, get involved in the community. Contribute to an open source project or test your skills in a Kaggle competition. This stuff shows real initiative and proves you can apply your skills. So there you have it, the complete roadmap. From writing your very first line of Python to specializing in a cutting-edge field and getting hired. If you follow this plan, you will have the incredible power to build the future of technology. And that leads to the most important question of all. Once you have that power, the real challenge isn't just what you'll build, but how you'll choose to build it responsibly.